Welcome. Let's take a look at an example of using implicit differentiation to find the derivative or the rate of change dy dx for the equation cosine of x equals x times the quantity 5 plus tangent of y. So to get started, we want to take the derivative with respect to x of both sides of this equation. So we'll have the derivative with respect to x of cosine of x plus or equals the derivative with respect to x of x times 5 plus tangent y, that quantity. Now notice I said x times. So keep in mind that whenever we have this multiplication occurring, we will want to be using the product rule as we find our derivative. So starting on the left, the derivative of cosine of x is negative sine of x equals, and now we need to use the product rule. The product rule tells us we will take the derivative of x, or the first function, times the second function, plus the derivative of the second function, in this case 5 plus tangent y, times the first function, which was x. And then we still have those two derivatives to find. So we have negative sine of x equals, now the derivative of x is 1, times 5 plus tangent of y, plus the derivative with respect to x of 5 plus tangent of y. Well, the derivative of 5 is a constant, so that derivative is 0. You can write it or not. Plus, now the derivative of tangent of y. So because our derivative is with respect to x, and we have the variable y, we're going to be using the chain rule. And the derivative of the tangent function is secant squared. So we're going to have secant squared, let's leave the argument alone, and then multiply by the derivative of the argument. In this case, that's dy dx. And our argument there was y, and then times x. At this point, we want to solve for dy dx. So notice that dy dx only appears in one location in this equation. So let's go ahead and subtract 5 tangent of y from both sides of the equation. And this leaves us with negative sine of x minus 5 plus tangent of y equals, and then on the right hand side, what we're left with is this x times this secant squared of y dy dx. So x secant squared of y times dy dx. And now at this point, all that remains for us to do to solve for our dy dx is to divide both sides of the equation by x secant squared of y. So divide by these two factors in front of dy dx. So we end up with, and when I do this, because I see that both the sine of x and the 5 plus tangent of y are negative, I'm going to go ahead and factor that negative in front. So negative of, or opposite of, sine of x plus 5 plus tangent y. And now because I factored that negative from the 5 tangent of y, I've pulled that out in front of a grouping symbol in front of parentheses. I no longer need these parentheses around the 5 tangent of y. So I really just have the opposite or negative of sine of x plus 5 plus tangent of y, that whole thing, divided by our x times secant squared of y equals our dy dx. And there we have our derivative for the equation that we were given. I hope you find this helpful.